Okay, so today we're going to do our notes video on Chapter 10, Lesson 7, involving box plots. Please open up your book to page 835. The new word today is box plots, but we're going to be reviewing some words we already should know, which are dot plot, a number line in which we're going to place data, and then we're going to use that picture to find the median, the first quartile, the third quartile, and instead of calling it the least value piece of data, we're going to describe that as the lower extreme, and then we're going to describe the upper extreme, or the greatest value. We're also going to be reviewing percent as well. Okay, so this says the table shows the number of touchdowns scored by each of the 16 teams in the National Football Conference in a recent year. What percent of the teams scored more than 35 and 5/10 touchdowns? Okay, so here is the group of all the data. The first thing we're going to do is we're going to put all that data by um, crossing them out one at a time, placing each dot on the number line to create a dot plot. So I'm going to give you a chance to get started with that. But before we get started, I will be asking you, once we get it on the dot plot, what has the least value, which is the lower extreme, and which data point is the greatest value, or the upper extreme. So I'm going to pause for us to put the dots on. Okay, so once we've got the dots on here, and if you didn't do the dots correctly, please pause this video and make some adjustments. Answer this question for me first. What is the lower extreme? What's the data point with the least value? Go ahead and answer that for me, please. All right, very good. If you said 24, you are correct, because if you look at the dot plot, 24 has the least value. Which number has the greatest value? What's the upper extreme? Go ahead and answer that for me, please. Very good. That answer is 54. Now, as far as quartiles go, the first quartile we need to determine is actually Q2, and Q2 is the same as the median. So let's find the number that's exactly in the middle. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 16 pieces of data. So we're going to start from the left side, and we're going to count in 8. Go ahead and figure out what the median number is. Go ahead, answer that for me, please. Okay, so if we count 8 from the left and we count 8 from the right, we're going to find that the median is going to be halfway between 37 and 38. So what number is halfway between 37 and 38? Well, that is going to be 37 and 5/10 is going to be our median. Okay. Now, and you'll notice, hey, look up here, 37 and 5/10, woohoo. So what percent of the team scored more than 37 and 5/10 touchdowns? Okay, let's go ahead and continue by figuring out the first quartile and the third quartile. So what we've just done here is we divided all the data in half. The median is halfway between the lower extreme and the upper extreme. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. If there are 8 pieces of data in the first half, well, what's half of that? So we have 1, 2, 3, 4. And then we have 1, 2, 3, 4. So somewhere between 28 and 34 is going to be the first quartile. So let's see, 28, 29, 30. 31, 32, 33, 34. So there are 6 places in between. Half of 6 is what number? 3, that's exactly right. So that means the first quartile is 3 more than 28 and 3 less than 34. So the first quartile will be what number? Answer that for me, please. Very good. The first quartile is 31. Okay, let's do the same thing over here. So the second half of data also has 8 points. So we're going to count 1, 2, 3, 4, and 1, 2, 3, 4. So what is halfway in between? What's the halfway number of the of the second half of data? Go ahead and answer that for me, please. Okay, it's going to be somewhere between 44 and because we have 1, 2, 3, 4, 44 and 47. So 44, 45, 46, 47. That's going to be 3. What is half of 3? That's exactly right. 1 and 1.5, 1.5. So 44 plus 1.5 is going to be 45. It's going to be just right here. It's going to be 45 and 5/10 will be the third quartile. Okay. What percent of the team scored less than 31 touchdowns? Well, if we come over here, 31 was actually our first quartile. So 1, 2, 3, 4. Quartiles means it was cut into 4 pieces. So one of those 4 pieces, what is the percent equivalent to 1/4? That is going to be what? 20 what? Very good. 25%. Okay. So, and then what percent scored more than 37 and 5/10 touchdowns? So 37 and 5/10 touchdown was the median. So we have 2 of the 4 sections are more than 37 and 5/10. So what is the equivalent fraction for 2/4? That's going to be 1/2. What is the equivalent percent of 1/2? Go ahead and answer that for me, please. Very good. That is going to be 50%. So the answer to how many teams scored more than 37 and 5/10 touchdowns, that is going to be 50%. Okay, now that wasn't difficult to do on with the dot plots, but we're going to be learning today how to use a number line. Instead of making a dot plot, we're going to do something called box plots, and that's going to involve a box and something called whiskers. So we're going to find out what that is in just a moment. Okay, so this is what a box plot looks like, or they also call it box and whisker plots. They use a number line just like dot plots do. They actually divide the data into 4 sections, so it's important that we know what the median of the data is and the quartiles and the extreme values. Now, the box actually is around the second and the third quartiles. So you're going to find the first quartile and you'll find the third quartile, and that's what you'd use to create that rectangle. And the line that's in the middle of that data is going to be representing the median. Now, the whiskers are made by a line drawn from the first quartile to the lower extreme, and from the third quartile to the upper extreme. However, if the upper extreme is an outlier, then the whiskers do not extend to that outlier. All right, so please read through the examples they do for you. This particular one's talking about car speed data. The very first thing you'll need to do is put this in order from least to greatest, and then you draw on the number line, marking the lower extreme, the first quartile, the median, and the third quartile and the upper extreme. And you'll notice that they put the box, the left side of the rectangle is the quartile 1, the right side is quartile 3. Now you'll notice the median is not always going to be in the middle of that rectangle. In this particular case, we have whiskers coming out, and there is not an outlier in this particular set of data, so you're not going to see another star point outside of the whiskers for that one. Okay, so again, I'm not going to explain every single example to you because you can read through those on your own, but we'll be doing one more example together as far as how to draw a box plot and how to interpret the box plot. Okay, so once you're able to draw a box plot, then you have to figure out, okay, what can I say about the box plot? So if we go back to the box plot on example 1, which you are in just a moment, half of the drivers are driving faster than what speed? Okay, so halfway is the median. So the median is 25. So half of all the drivers were driving faster than 25 um, miles per hour. So that's exactly what it's saying. Half of the 11 drivers were driving faster than 25 miles an hour. So that's one thing we can tell about that plot. What does the box plot length tell you about the data? Okay, so if I come over here, this is the median right here, and this is the first quartile, and then the very least value here. You'll notice that half of all the drivers were kind of concentrated and about the same speeds, less than 25 miles per hour. But the people that were going faster, the half that were going faster, do you see how the data is a whole lot more spread out? So some people were going way too fast, and some people were going a little bit too fast. So again, that's what this says here. The length of the left half of the box is short, which means the speeds of the slowest half of the cars were concentrated. The speeds on the fastest half were really spread out. Okay, so let's do one example where we're drawing a box plot together. All right, so we're going to draw a box plot together. This is the guided practice number 1. The first thing that I did was to write all of the data out from least to greatest, from the lowest extreme of value to the greatest extreme of value. Okay, so now we need to find out what is exactly halfway in the middle, and if there are 1, 2, 3, 4, 5, 6, 7, 2 rows of 7, what's 2 times 7? Great, 14. So half of 14 is 7, so we need to count 7 in from each side to determine the median. Go ahead and do that for me. What is the median of this data? 1, 2, 3, 4, 5, 6, 7. Okay, so the median is going to be somewhere between 5 and 7. So what is that? What is halfway between 5 and 7? Very good. That answer is 6. Okay, so I didn't do a very good job drawing a line there, but that 6 is the median. All right, so now where you'll have to find out the first quartile, and basically quartile 1 is the median of the first half of data. So if we look at only the numbers that are before the number 6, what number is halfway in the middle? So 1, 2, 3, 4, 5, 6, 7. So what number is exactly in the middle of those numbers? Go ahead and answer that for me, please. If you said 4, you're correct. And so if you look at this, we have 1, 2, 3, and then we have 1, 2, 3. So there are 3 numbers to the left of 4 and 3 numbers to the right of 4. So quartile 1 is going to be 4. Good job. So I'm going to go ahead and draw that line over here where the 4 is. All right, so remember our job here is we're going to actually create a rectangle between quartile 1 and quartile 3. So now we look at the second half of the data. There are 7 numbers. So what is halfway in the middle of those 7 numbers? Go ahead and answer that for me, please. All right, if you said 9, you're correct because 1, 2, 3, 9. 1, 2, 3, 9. So quartile 3 is 9. So we're going to draw another line over here at quartile 9. Now we're going to go ahead and connect that to create our rectangle. So that's our box. So exactly 1/4 of the data, well, actually take it back. So this is quartile 2 and quartile 3. This is the upper, this is where quartile 1 ends. This is where quartile 3 ends. And now we need to draw our whiskers. So first, before we do that, we have to determine if we have any data that is an outlier. So we have to actually calculate our IQR. Now, the range of the data is we take the greatest number and you subtract the least number. So 14 is going to be our range because 15 minus 1 is 14. But our IQR is when we take quartile 3 and we subtract quartile 4 from that. I mean, quartile 1 from that. So 9 minus 4 will give us what our IQR is. So what is 9 minus 4? Very good. If you said 5, you are correct. Now, as far as determining the outliers, we have to do a little multiplication here. We don't want to consider any data that is more than 1.5 times greater than the IQR, or more than 1.5 times lesser than the IQR. So we're going to take the IQR and we're going to multiply that by 1.5. So go ahead and solve that for me, please. Okay, if you got 7 and 5/10, you're correct. That is the magic number here. So what we do is we take the least value, the 4, and that's quartile 1, and we're going to subtract 7 and 5/10 from that. And if any data is less than that, then it's an outlier. But as you'll see, our lowest value is 1, and this would actually be a negative number. So there are no outliers on the lower range. So what we're going to do is we're going to put a dot at the least value, which is the lesser extreme, and we're going to draw a line to our box, and that's our first whisker. So there are no lower end outliers. Now, if we come over here to quartile 3, which is 9, if we add the magic number of 7.5, we can determine whether there are any outliers on the other range. And so we're going to go ahead, and that's going to be 16 and 5/10. So if we look at the data, is there anything greater than 16 and 5/10? Answer that for me, please. No, there's not. So there actually are no upper end outliers either. So I'm going to find the upper extreme, which is 15, and we're going to put a dot there, and you'll notice that this whisker is quite a bit longer. That's going to be our other whisker. So this is a box and whisker plot. So now what we're going to do is we're going to answer some questions to interpret this data. The first question is, what percent of the earthquakes are between 4 and 9 kilometers deep? Okay, so if you'll notice, we have 4 right here, and we have 9, which is quartile. We're quartile 3, and then 4 is quartile 1. Well, as far as quartiles go, we're cutting this data into 4 pieces, and if this involves 2 of the 4 pieces, this is what we need to think about. 2 out of 4 pieces are between 4 and 9 kilometers deep. So 2/4 is equivalent to 1/2. What percent is equivalent to 1/2? Go ahead and answer that for me, please. Very good. Half of a dollar is 50 cents. That is the same as 50%. Okay, write a sentence explaining what the length of the box plot means. Okay, so here's the median. And we notice that this side is quite a bit shorter. This side is quite a bit longer. What's something we can say about that? Okay, now there are quite a few things we could say about it. We notice that between 6 and 15, that's about 9. The difference is about 9. Between 1 and 6, there is 6. So that's the value of 6. So we could say that more of the earthquakes it was more spread out. The second half of the data of the earthquake was more spread out than the first half was. We can say that really all of the earthquakes and the depths were kind of spread out. There's no really centralized number that it mostly was. We have 555, which is the mode, but we also have 7 and 7 and 9 and 9. So it's kind of spread out. So really, that would be my interpretation, is there's no centralized length that it mostly was. But if I had to say something, the half of the data that was greater than 6 was more spread out than what was less than 6. Okay. So I want you to think about this. What was the most important thing that we need to remember about box and whisker plots? Think about that carefully. Answer that for me now, please. Thank you for your thoughtful response. Please come into class. We're going to do some more examples together. Please watch other videos to help support you and read through the notes in the book. Thank you.